everyone, in this video we are going to learn about different sorting techniques in JavaScript, which is of course super important for the interview. So let's get started. So let's start with bubble sort. Bubble sort compares the adjacent elements, and if they are in the wrong order it corrects it. In short, we will just take the largest element and keep moving it to the end. Of course, we'll understand better with the example. Let's start. So I'm actually taking a completely unsorted array, so it will be easy to understand. So 5, 4, 3, 2, 1. So we are iterating over the array and we will keep checking the adjacent element. We are checking the adjacent element. If they are not in correct order, like not in the increasing order, we will move it, we will swap them. So 5 and 4, 5 is larger than 4, so we are just swapping it. Now the next two adjacent elements, 5 is greater than 3, we will swap it. Next to adjacent element, we are doing the same thing, and the next two. So this was our first iteration, and after the first iteration the largest element is at the end, if we notice. So this is what bubble sort is. We are bubbling up the largest element to the end. We will do the same. Now what we will do is we will only check these elements, because now we know that the largest element is at the last, right? Why to check that? That is actually at the correct place. So let's see. We are at the second iteration. 4, 3, 2, 1 and 5. We will not touch 5 here. We will just check till 4, 3, 2, 1. So again, adjacent element, if they are not in the correct order, we are just swapping it. 5 will be at its place. So 4, 2. We just swapped 2 and 4, and the last one we will check 4, 1, and we are swapping it. We will not touch 5 because we know that in the first iteration the largest came to the end. So now in the second iteration we were just concentrating on 4, 3, 2, 1, and the largest element from 4, 3, 2, 1 was 4, which again came to its correct position. So we are bumping up, we are bubbling up the largest to the end. This is what bubble sort is. Let's actually dry run the full example to have a better understanding. So now we have 3, 2, 1, 4, 5. Now we know that after 2 iterations, the last 2 places of the array are in a correct order. They are actually sorted. So we'll just concentrate on 3, 2, 1 this time. Again, adjacent element, if they are in a wrong order, just swap it. 2, 3, 1, 4, 5. Adjacent element, if they are in the wrong order, swap it. Of course, we will not check the 1 and 4 because we know that 4 is at the correct position, so there's no need to check it. So again, in the third iteration, we got our largest element from these 3 at the end, because we were not actually considering 4 and 5, right? So if we just imagine that 3, 2, 1 is a independent array, and from largest element is 3, and that actually came to the end, so it's at the correct position now. So let's continue the dry running. Our fourth iteration, we have 2, 1, 3, 4, 5. And from these we will not touch 3, 4, 5, as we know they are at the correct position. We will just check adjacent elements here. If they are they are not in a correct order, we are just swapping it. So now we just checked this. Now a question to you is, will we swap 2 3? You can stop the video and think about it. Will we even check this 2 3? So the answer is no, we will not check, since we know that 3 4 5 is at the correct position. So this is it. At the end we got the sorted array, right? So yeah, this was the algorithm bubble sort. Kind of remember what bubble sort is about. You can think bubble sort just bubbles the largest element to the end. I think if you remember this particular line, it will be pretty simple. You'll remember the algorithm. We are checking the adjacent elements and swapping it if they are in the wrong order. And after each iteration, we will get the largest element at the end. Perfect. So how to actually write the code for this? This is I think understanding the algorithm dry running, that is pretty simple and everyone understands it, but how to actually write the code of it is the main thing. We will be doing the code in JavaScript, so let's see how to write the code of it. So what are we doing it? Let's try to understand it. So we are just running loop and we are checking adjacent elements. If they are not in order, we are swapping it. So I hope you understood how the algorithm works. I would recommend you to try with 2-3 more examples and see at the end, are you getting the sorted order. You can try with different examples. Maybe take a large array and try it. Now the main point is how to write the code for it. This is where most people get stuck, right? So after dry running, we got to know that we have to run 2 loops, right? So the first loop is for the iterations, like this is 1 2 3 4. This is what we do, right? So let's say we will have our first loop where we will decide our I is like a variable, and in the second loop we will let's say second loop is j. We will check if the adjacent elements are in a correct order or not, and if not, we are swapping it. So how to decide? So see, it's pretty simple to understand that we have 2 loops, right? Because you see that in the first loop we are checking and we get the largest element at the end. Again in the second loop we are checking and we get the largest element at the end. But the twist is that we are checking till we are not checking the last element in the second loop. In the third loop, last 2 elements we are not checking. In the fourth loop, last 3 elements we are not checking. So we kind of have to find a pattern, or we have to find the positions of from where to where we have to run the loops, right? So I have taken a completely unsorted array, so it will be pretty easy to find the positions of I and j. Let's start with I. So let's say I is 0 here, I is 1 here, I is 2 here, and I is 3 here. And what is n? Like n is the number of elements in an array, so we have taken 5 as the number of elements in an array. So I hope you understood that we are running I 0 1 2 3 and n is 5. So n is 5 and we are actually iterating 4 times. So I can say till 4, right? if we consider it index wise, so it will be 0 to 4. It means we will be running our loop from I minus 0 to n minus 1. So I hope you got how many times we'll be running our first loop. Let's actually understand about j now. We got to understand that I will be, if there are 5 elements, we are running I till 4. If there are 7, so I will be till 6 times. But what about j? Is always we are starting j from always 0, right? Means if we are starting a loop, we are always starting from the very beginning. So j will be starting from 0 and ending till. Now ending is very important, since we are since in the first iteration we got that that the largest element will come to an end, right? So let's understand in the first iteration till what part we were running j. So j was 1, 2, 3, 4, 5 times. I mean j is 4 times here, means we are checking this 1, then 2, 3 and 4. So first one was just the example, then we are running it for 4 times, right? Now in the second iteration, how many times we were running it? So again, first is just the example, the actual running of loop we are starting from here. So 1, 2, 3 times, and then in the third part 2 times, and in the fourth iteration 1 time. So j kind of is getting run like 4, 3, 2, 1, right? And let us see how many elements we have. We have n as 5, and so kind of we just have to find a formula so it fits this answer, right? And I is, here I was 0, here I was 1, I was 2, and I was 3. I think it's pretty simple now. We have n, we have the answer, and we have I, so we can just find out till what like we have to find out the formula of j. So let's say 5, n is 5, so what we will do, 5 minus, let's say I, 0 minus 1, so we will get 4. So our formula is coming out to be n minus I minus 1. Let's just check for other values as well. So 5 minus 1 minus 1, it will be 3. 5 minus 2 minus 1, it will be 2. 5 minus 3 minus 1, it will be 1. So I hope you understood the formula. This is how we came that j will be running till n minus I minus 1. I know it's pretty messy here. I'll probably go down. So we got to know that I is starting from 0 and ending at n minus 1, and j is also starting from 0 and ending at our formula n minus I minus 1. So this is our first loop, and this is our inner loop. Inner loop will check the adjacent elements. Adjacent elements will be like, if array of j is greater than array of j plus 1, then we have to swap both the elements. Swap array of j. I'm just writing the pseudocode. So swap is not a inbuilt function in JavaScript, so we will have to understand how to swap two elements. Of course, I'll be coming to that part. So let's say we have a array 1, 2, 3, and we have to swap array of 0 and array of 1. Means we have to swap 1. So the output should be 2, 1, 3. Okay, so for swapping an array, we can actually let's say I want to swap 1 and 2, right? So I will take a temporary variable and I will store 1 here. Okay, so I am doing temp equals to array of 0, and inside array of 0 I am storing array of 1. Means this element I am storing in a temporary element 1. Then I said ki in array of 0 just place array of 2, array of 1, that is 2 I am placing here. Now here in array of 1 I want temp, so this is swapped. So I'll just do a dry run so you would understand. So previously we had 1 2 3. Our goal is to achieve 2 1 3. I'm just explaining you how we are swapping it. So in temporary array we can store array of 0, then array of 0. Inside array of 0 we can put array of 1, that is I'm crossing this. Inside array of 0 we are putting array of 1. Now inside array of 1 we can just put our temp because we have stored our value initially, so it doesn't get lost. So now in the array of 1 we have temp. So these are the only 3 steps of swapping. So now we understood from where to run the loops. We understood how to do the swapping. It is pretty easy to write the code. So let's write the code. I'll be writing the code in JavaScript, but of course you can write the code in whatever language you are comfortable in. So let's start the code of bubble sort. JavaScript compiler. So let's write the code for it. Let's say we have an array. We can take the same example we used for dry running, and let's create a function of bubble sort which will take an array. At last we will be calling this function with our variable which will return our result, and we will print the result. So here is what we have. Here is when we have to write our main logic. So we have to run 2 loops. First loop will be starting from I0 to I equals to n minus 1. Pretty simple. I'll just create n. Second loop will start from j equals to 0 to I hope you remember the formula we created, that is n minus I minus 1. Now inside this we just have to swap. If array of j is greater than array of j plus 1, just swap them. We know that how to sort 2 elements. So the first element we can store it in a temporary array. Inside the first element we can give the value of the second element. Inside the second element we can give the value of temp, because that's where we have stored the value of the first element. With the help of this we have swapped them. So after 2 loops we can just return the array, and this should give correct answer. This should give correct answer, so let's run it. So yeah, our array is sorted. I can take few more examples as well if you want. If I run it, it should return sorted array. Perfect. So let's understand the time complexity of this. We are running two loops in this. So the time complexity is big O of n square, and we are not using any extra space. So space is big O of 1. But let's say I'm taking 1, 2, 3, 4, 5. I'm taking a sorted array, right? And still we are looping over it and kind of swapping it over it again and again. So for our code, the best case scenario means if our array is already sorted and we are running our function over the same array. So now it's big O of n square only. But why will you swap the same elements, right? Like, why are we doing the second loop over this? Because it's already sorted. So our time complexity is big O of n square for the worst case and for the best case. But of course, for the best case in bubble sort, we have to kind of improve our time complexity. So let's think over this. We can take this example and dry run our code for this. So let me open the book. Let's take the example for the best case scenario, that is 1, 2, 3, 4. Okay, we can take a small array, so it will be faster in dry running. So this is the best case scenario. We will be running our loop and we will be checking our adjacent elements. So this is in this case I is 0 and we are running our first loop. So here we will be checking these two. So now we are starting our second loop. In this we are checking is 1 is greater than 2. So if 1 is greater than 2, we will swap it. So 1 is not greater than 2, so it will be same. Then we will compare 2, 3, it will be same. And we will compare 3, 4, it will be same. So here we are not going inside if, right? So if we are not going inside if case, that means the array is already sorted, right? So in between, if we are going inside if, then we can understand that array is unsorted. So here we can actually optimize it in one way, that we can take a flag swap, and initially let's say it's false, and if we are going inside we can make it true. Okay, if we are going inside if, it means the array is unsorted and we have to continue our algorithm, but we are not sorting and the j is over, like the j part is, if you are not sorting in one particular second loop, we just have to break it, we don't have to repeatedly check it, it means. So here we can do if swap is not equals to false, we can just return. So in this way we have just run one loop and we are breaking the I loop, so it will not move further. If I run it, so let's actually see if it's going inside this. So this is not printed, it means swap will be always false and we'll be just returning from here. You can check here by putting logs also. So we'll be going inside that. If swap equals false, if swap is still false, we have to return it. So we have to return the array. So yeah, so this worked. So now the time complexity in the best case is we go of n, because we are not actually running the second loop for that, right? uh, Perfect. I hope you understood bubble sort. In the worst case, the time complexity is big of n square. In the best case, with the help of a swap variable, we optimized it to big of n. And of course, we are not using any extra space, so it's big of 1. Perfect. So this was all about bubble sort. See you in the next video, and we will learn about selection sort. I hope you understood bubble sort. I would recommend to try it with at least 4 to 5 examples, and then you will get it properly. Also, in the next video, I'm gonna explain about selection sort. Do subscribe to the channel, like the video, and share it who is preparing for the interviews.